Welcome to this explainer of the OMI Protocol. Today, we're going to unpack how this incredibly dense mathematical framework is totally revolutionizing decentralized state management and, honestly, creating an internet that literally cannot be hacked. Okay, let's quickly map out our journey for decoding OMI's novel lexicon today. 1. The flaw in hashing. 2. Place value identity. 3. The 4 protocol authorities. 4. Hardware safety through laziness. And 5. Geometry-driven determinism. Let's get right into it.
Section 1. The flaw in hashing. Why standard identifiers are breaking decentralized systems. We are starting our journey today by completely dismantling a foundational assumption of modern computing.
For decades, systems have relied on hashes to identify data. But OMI steps back and asks a really profound question. What if hashing is actually the wrong way to identify information inside a deterministic system? You see, when you use a hash, you're taking a body of data and transforming it into a fixed surrogate sign. You're basically slapping a random label on it. And inside the OMI protocol core, creating this surrogate label fundamentally breaks determinism. It creates this second identity channel right next to the actual data address, which the protocol sees as a massive category error. A hash points away from the underlying relationship and into a substitute label. So OMI argues that if a system relies on these arbitrary labels, it can never ever be perfectly mathematically deterministic.
Which leads us to Section 2. Place value, a new identity. Returning to the root relation.
Think about the stark contrast between our old mental model and OMI's approach. OMI essentially throws out that arbitrary name tag of a hash and replaces it with a direct geographic coordinate, which they call place value identity. In OMI, the addressable relation itself is the identity. Imagine the difference between calling a building the Empire State Building, which is, just a name tag, versus identifying it exclusively by its exact longitude and latitude coordinates. The OMI notation cascade preserves the root structure of the data directly within its address. Every single piece of data is identified by its precise geometric location in the system. That means any operator can perfectly trace the structure back to its root relation without ever having to rely on a compressed, one-way hash.
Section 3. The 4 protocol authorities, following an intent through the pipeline. To see how this identity moves, let's track a real-world example, an intent to open an ESP32 connected door through OMI's 4 unyielding authorities.
So, the absolutely crucial point here is that this pipeline is strictly one-way and irreversible. Let's say you click a button to open a door. First, we hit the OMI authority, which handles the cite phase. It parses your intent and frames it as a structured coordinate. Next, it moves to the validate phase, which is managed by the tetragrammatron. Then, that decision is permanently recorded in the record phase onto what's known as the receipt ring. And finally, the project phase is handled by the Metrotron, which actually tells the hardware to physically move. This flow goes from the initial citation of the open door intent all the way down to the physical hardware projection, and it never, ever skips a step.
Let's pause on that validator for a second, the tetragrammatron. This authority is absolutely central to the whole operation. It doesn't care about a hash at all. It only accepts a command if it perfectly fits the immutable mathematical rules of the system. The tetragrammatron is the exclusive boundary between a request and reality. It takes the parsed citation, our request to open the door, and tests it against hardcore deterministic equations. If the math checks out, the tetragrammatron accepts it and writes it permanently to the receipt ring. Once a receipt is in that ring, it is immutable, canonical history. Okay, so once it's validated and recorded, the Metatron takes over. The Metatron is the projection authority. It reads that immutable receipt from the ring and adapts it into something tangible. That could be rendering an image on a screen, or in our door example, sending a signal to the physical ESP32 lock. But here is the brilliant constraint. The Metatron has absolutely no authority to validate or accept anything on its own. It is completely blind to unvalidated requests. It only projects what the tetragrammatron has already permanently etched into the record.
Section 4. Hardware safety through laziness, the golden rule of evaluation. Let's look at how this strict separation guarantees flawless physical safety for hardware like our door lock.
This beautifully illustrates a concept called lazy evaluation. In traditional systems, when an event or syntax appears, the hardware often just reacts immediately. Not in OMI. The physical door does not actually unlock until the intent has been fully validated and permanently recorded. You declare the intent, the tetragrammatron mathematically proves it, the receipt gets etched into the ring, and only then does the hardware actually actuate.
The foundational mandate here is simple. No side effects before receipt. If validation fails, for any reason whatsoever, absolutely nothing happens. Zero. There is no physical actuation based on unverified, incomplete, or malicious commands. The hardware literally cannot fire because the projector only reads from the permanent, validated receipt ring. This lazy evaluation totally isolates the physical world from the chaos of unverified data.
Section 5. Geometry-driven determinism, the mathematical bedrock of OMI. Let's dive into the underlying math that makes this absolute, unbending determinism possible.
Take the number 5040. It's not just some random figure. There are exactly 5040 specific slots in the Fano-addressed receipt ring where our door opening command can be permanently stored. This number is entirely geometrically derived. The ring addressing is based on the 7 points and 7 lines of a geometric structure called the Fano plane, combined with specific factorial hierarchies. Every single piece of validated data has a mathematically precise slot it belongs in.
The real magic behind the curtain is that everything in this protocol is exactly derived from the geometry of that Fano plane and verified by Coq mathematical proofs. A Coq proof is a machine-checked mathematical certainty. This means there are 0 approximations in OMI, none. Even constants like pi are not stored as approximate numbers. They're derived exactly through geometric rules like the Gregory-Leibniz expansion. Simply put, there are no rounding errors and no floating point fuzziness. Because there's no approximation, the system achieves perfect determinism. The exact same input will always yield the exact same output, every single time, safely verified by math.
We'll leave you with the covariant rule. It's the ultimate philosophy of OMI that enforces this perfect safety and mathematically grounded reality across every layer of the system. It states, no layer is authority by itself, and validation is the exclusive boundary between canon and cosmology. Canon is the verified truth, the receipt ring. Cosmology is how we view it, the projections. By strictly enforcing this boundary, OMI creates an environment where malicious code, hardware misfires, and data collisions simply mathematically cannot exist.
This leaves us with a totally fascinating question to ponder. Because OMI is perfectly deterministic, multiple peers can synchronize an identical open-world state simply by exchanging these validated receipts, with zero need for a central global database. So, if we can eliminate all approximation and ambiguity at the hardware level using this strict place-value identity and geometric determinism to secure a simple door lock, what happens when we scale this absolute safety to the entire internet? Think about the implications of a truly decentralized, mathematically perfect peer-to-peer network. That's the real power of the OMI protocol.